At last, we can now start creating our project. We will open Alice 3 and initialize an Alice world. We will be picking a seafloor template. Step 3. Adding props. We go to Setup Scene, and we start by adding a camera marker for the start. We can call this camera marker Spawn. This will be helpful if you want to go back to the original position. Next, we can add a few decorations such as seaweed, sandcastle, starfish, and rocks. We can add a prop by searching it in the gallery and dragging it to the scene. In this example, we will be adding some seaweed. You can add as much as you like, but for ours, we will keep it minimal. Step 4. Adding the treasure. We will be adding 5 treasures, as in 5 gems. Make sure they are in locations that are not too obvious, but are also easily reachable. Step 5. Adding the player, spawn, and setting the camera. Next, we add the player, which is the clownfish, drag it, and create an object marker called start. This is helpful for when the player respawns. We also set a camera marker, actual start, behind the player. This is the initial position of the camera when the game starts. Putting the camera at a distance behind the player is called puppeteer locomotion. There are other styles of movement for VR, which you can check at the Alice website. The next step is to add player properties and the spawn procedure. So we go to the code editor and then select the clownfish and add a property called isActive. IsActive is a boolean that stores whether the player is playing or not, as in whether the player is in the winning or losing state. Let's initially set it to true. Then, we add another property called score. This is a whole number that stores the player's score. After that, we create a spawn procedure under the clownfish class. So when it's called, it moves the player to its initial position. So we need to add a parameter called sThingMarker, and we call it spawn. So we will pass the object marker to this procedure. Actually, let me rename it to location instead. Okay. Next, we want the move to procedure to be instant, so that the player spawns instantly. Then, we want to change the opacity to 1, so that the player appears. We also want to add a message, which will show at the beginning of the game. Let's say something like, collect all the gems and avoid the sharks. And we will add this at the center for 1 second. The next step is coding the player movement. We will use event listeners for arrow key presses. Click on the Initialize Event Listeners tab. Then, click on Add Event Listener for arrow key presses. Then, we edit the event listener by setting the held key policy to fire multiple. This is important as the player can hold the keys for smooth movement instead of rapid presses which can get uncomfortable. Next, we add an if statement. We want to check if the player is active. They should only move if they are in the playing state. If they are in the playing state, then we check which key they pressed by using the isKey event. If it is left, then the player turns left. Else, if the pressed key is right, then the player turns right. With this way, we can make the player turn left and right. Note that each movement should have a small magnitude and short duration, and that it begins and ends abruptly. You can tweak those modifiers as you test the game later on. Next, if the key pressed is the up arrow button, then the player should move upwards. Else, if the down arrow key is pressed, then the player should move downwards. You can use the same modifiers as before, but remember, you can tweak the values as you test the game. For the down arrow key, we copy the code block that we just added, but we change the direction to downward. Next, we add an event listener for moving forward. We add a listener for key presses. And then, add an if statement, checking the key. If it is the X key and the player is active, then we can move forward. That's it. We now have completed the player's movement. Next, we run a brief test. Let us test our work so far and run the program. This is important to do on a regular basis as we progress through the project to fix bugs or mistakes. We can see here that the left and right arrow keys work, but the up and down motion is too fast, as well as the forward motion. We also notice that the camera is not following the player, and the props in the background are too small. So, running the program every now and then is very important to remove any bugs. So, let us fix those bugs. First, we set the up and down distance to 0.1, and the moving forward, we set it to 0.15. 15. 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 . 0.15 Now, for the camera to follow the player, we use the set vehicle method on the camera to follow the clownfish in the scene activated event listener. Lastly, I will resize the props off screen. Okay, so after finishing those edits, let us see our program so far. Great! The movement is nice and the scene is almost all set up. But not all features are implemented yet. The next step is to code the collecting feature. For this part, we want to be able to collect the treasure. So first, to make this easier for us, we will make a scene property of type array, consisting of all the rubies in this scene. We will call this treasure list, and we will add all of the rubies into the array. Make sure that there are no duplicates. Next, we add a property to the Ruby class called isNotCollected. This is a Boolean that's tracking if the ruby has not been collected yet. Let's initialize it as true, since at the beginning the rubies are not collected. Next, we add under the Ruby class a procedure called collect. This will be called when a particular ruby is collected by the player. Inside the method, we set the opacity to 0, making it transparent so that the ruby fades. Then, since it's now collected, we set the isNotCollected property to false. Next, we also add a spawn method for the Ruby class. This will be called when the game restarts and the rubies have to appear again. So we set the opacity back to 100 and set the isNotCollected property to true. Next, we add a procedure under the clownfish class called playerCollect. This is the action of the player after collecting a treasure. We do this by setting the score to the current score plus 1. Then, we show a message of the current score. And we make it appear in the center. Okay. Next, we go back to the event listeners. Here, we will add an if-else block. This if-else block will check if the button pressed is the Y button. Inside it, we also add an if-else block checking if the player is active. So, if we press Y, and if the player is active, then we further check if the player is colliding with any of the props. For that, we use a for each n over a Ruby array using the scene property that we created earlier, and we call the individual object treasure. So for each treasure, if the clownfish is colliding with the treasure, then we call the treasures collect procedure. So what will happen is that the treasure will be collected. Hence, it will disappear. And then the clownfish calls its own collect procedure to update the score. Okay, so now you can briefly test that the feature is working as intended. Great.